Hello, the topic of today's lesson is displaying data in line plots. Line plots we've been studying since third grade, and we used them in fourth grade, and finally now we're in fifth grade and we're still working with line plots. Line plots are a number line that goes from left to right that has numbers, but not all the numbers. You start with the minimum, with the smallest value of your data, to the maximum or the largest value of your data. And this range, this area, right, of all the data points we call range, from smallest to the largest. So let's read the problem that uses the line plot to visualize. It's a visualization tool. We're using a line plot, a number line with some plotted points, in order to visualize what our data looks like, because we're all visual people. To see a table is much more difficult. When we see a picture, when we see a graph, it's much easier for us to see what's going on. So manufacturers of sportswear claim that clothing made of synthetic fibers, such as polyester or nylon, wick away moisture faster and better than cotton. It is true if you think of all the clothing that we use for playing sports, whether it's a swimming suit or whether it's a soccer gear or maybe we go for a run, it's all made of synthetic fiber. Why? Because it dries much faster on the body. Jake did some experiments to see if that was true. He soaked 8 square patches. So he created like this little 8 patches of fabric of polyester and nylon and cotton and submerged them in water. And for each square, he draped it over a little cup and, left it there overnight. And what happened, that's water. That's not a human face. He collected some water in a cup after a whole day. As time passes, the water moves through the fabric just like that and drips into the smaller glass. The water collected is moisture that's been wicked away, and after 24 hours, Jake measures the volume of the water in the cup, and he records his measures. So in blue, I have recordings for polyester fabric. In red, I have recordings, the water samples collected from nylon patches. You see, we have 8 patches. And of course, we have 8 patches of cotton, but guess what? Cotton is really bad at evaporating moisture. It absorbs everything, but it doesn't evaporate. So the water never transfers to a cup. That's why we have 0 cups for all of our samples, which is perfectly understandable. Then Jake plotted it on a number line. He created a number line. Again, number line is a line. It's a line where we have numbers and we plot our data. Notice for nylon, he used red color, right, matching our table, and for polyester, he used blue color. Notice that the data does not start from 0. This is the first measurement. And my friends, if we count the scale, 1, 2, 3, 4, 5, 6, 7, 8, these are 8s. So this is 6/8 or 3/4. And sure enough, right here is the smallest moisture volume for nylon, right? This is the first dot for nylon right here. This is the first dot for nylon, 3/4 of a cup. Look, we also have all the dots in green color for polyester. So which fabric was better at wicking away water? In other words, which fabric was able to transfer water into the cup next to the solution? And of course, we see that most of the green dots right here on the higher volumes that generated more water are made of polyester fabric, polyester. So we can say, yeah, which fabric? Polyester. Polyester. What is the difference between the highest, meaning your maximum value, and your lowest, meaning your minimal value obtained for each? So here we can say for P for polyester and for N for nylon. Let's talk about polyester. So the smallest was right here, and that is 1 1/8. And the largest collection was right here, which is 1 7/8. So what is the difference for polyester? It's 1 and 7/8. That's the most that Jake collected, and 1 1/8 of a cup, resulting in 6/8, which is 3/4. Now for the nylon measures, let's see. The smallest value was right here, 3/4, right? So 3/4 was the smallest volume, and the largest volume was right here, and it's 1 1/8, 2 1/8, 2/8, 3/8, right? So it's 1 3/8. So we can say 1 3/8 minus 3/4, which is 6/8, equals 3/8 and 3/4. I have to do my math, my friends, and I have to get back to you. I'm going to calculate it, or you should calculate it. Look at the plot. Without calculating, estimate the average amount of water wicked away by each fabric. Well, if we'll look, let me erase what I doodled on top here. Let's take a look at what we have for distribution of red dots. You notice this is the situation, right? This is the data collected for nylon fabric. What do you think is the average? What is the volume in between that's kind of to the center? I would say it's probably 1 1/8. I would think it's somewhere here, or maybe somewhere here, right? We have 1, 2, 3, 4, and oops, and we have 1, 2, 3, 4. So I would think just by looking, it would be 1 for polyester and for nylon. So for nylon, right? For nylon, the average should be about 1 1/8. And for polyester, right? For polyester, the average, let's take a look at the green dots, right? I'm going to mark them blue. We have most of the dots situated here, right? But we do have this outlier. We have this outlier right here. So we have to consider the outlier. And I would say that the average is about, I would think 1 5/8 or 1.5, maybe 1 5/8, just by looking at the graph. Now, here is where you use your math and especially your fraction addition. What is the average amount of water wicked away by nylon fabric? So this is for nylon. Nylon is red, right? So this is for nylon fabric. For nylon fabric, now we have to add up all these fractions. My friends, there's a way to do that if you just first collect the ones, okay? Collect the one, make up the ones. So 7/8 and 1/8 makes 2 plus 1, so this is already 3. Now, 3/4 and 1 1/4 already gives us another 2, right? Another 2. And then at the very end, right here, this section, let's add it up. What do we have? We have 3 wholes and 5/8. It's 3 5/8 plus 3 5/8. So let's record this. It means for nylon, the total number of cups, the total number of 8 cups whisked away was 3 plus 2 plus 3 is 6. No, 8. 8 5/8. But we have to divide it by the number of data points divided by 8. And if you do the calculation, it will become about 1, just like we thought it would be, right? 1 5/64. 1 5/64. So this is the sum of all the data points collected was 8 5/8. And the average amount is 1. If we split it into 8s, it is 1 5/64. Okay, so that's the accurate amount. Now let's do the same and calculate the average amount of water wicked away by polyester fabric, right? By polyester fabric. Above, we'll look at just the red dots, nylon fabric, and here we are looking at polyester fabric. Polyester fabric. Now here it's a little bit harder to add everything up, but it is doable. Take a look. 1 7/8 and 1 1/8. I can tell you right away, I hope you're with me, that it already makes 3. Another strategy, they're saying convert each fraction into its decimal. Another strategy is to add up just the whole numbers. So 1 plus 3 plus 1 plus 1 plus 1 plus 1 plus 1. Together we have 6 ones plus 3. We will definitely have 9 wholes plus. Let's add up all the fractions. Now, this is much harder job. 3/4 plus 7/8 plus 3/4 plus 3/4 plus 1/2 plus 5/8. And I encourage you to pause this video and do the math yourselves. I got here, I had it written down because I did my math. I think altogether here, I got, I have to recalculate. Oh, I got 13. Oh, so I got 4 and 1/4. And if I add up all my wholes and all my fractions, I will get 13 and 1/4, but I need, sorry, it's a quarter, and 1/4 divide by 8. And if I do all my conversions and divide the fraction, this is the final step in calculation, the average for nylon fabric will be 1.656. I converted it into decimal, 1.656. So we have two values, right? We have here 1 and 5/64, and we have the nylon fabric 1 and 6/56. So this is showing you what we can read from just looking at the line plot. Now, there are a few questions that we need to answer. What data values represented the most in the polyester fabric? Now, for polyester, polyester is marked in blue, right? Polyester is marked in blue, so, or green on the graph. What data is represented the most? I hope you see this, right? It's right here. It's right here. This, the most, oh no, so sorry, there's one more. Right here, right here. And that is 1 1 3/4, 1 3/4 of a cup. That is the most frequent collection. What is the difference between this, the most frequent, and the average? Well, 1 3/4 minus 1 and 5/68. The difference is very little, right? We would calculate, or 1 and 6/56. 1.75, which is 1 3/4 minus 1.65, right? Frankly, the difference is less than 1/100 or 1/10 of a point, which is very little. Now, what data value has the greatest effect on causing that difference? I personally think it's that outlier. It's that outlier measure when we collected so little water for a polyester sample. So I would say the only thing that's really skews our average is this outlier of 1 and 1/8, 1 and 1/8 data point. I hope you understand how we read the graphs, the line plots, the simple visualizations. In the next lesson, we will build our own.